All right, here we go. Section 1.3, sizes of sets. Okay, so basically, there's a bunch of examples, a couple little formulas that are important to know. So let's go ahead and work through this. We've got first example here. So taking a look, what this first means, the n, that means number in the set. So this means the number in our universal set. Okay, so right now we're told that A and B are disjoint. Okay, if you remember, that means they don't overlap in the Venn diagram. So let's draw a Venn diagram. Okay, they're disjoint, so no overlap. So there's A, there's B. All right, it says number in A is 25. Number in B, 15. Okay, we also know there's 50 in the whole set. So that leaves, what, 10 outside. Okay, so what we're finding is A union B. So that's A or B or both. Well, both doesn't apply here because they're disjoint. So A or B would be 25 plus 15, 40. So that's A union B. Okay. So little formula down here, you won't really use this very often because this only works for disjoint sets. Okay. But if they're disjoint, all you gotta do is add them both together, or however many there are. If there's 3 sets, you just add the third one in there also if you're trying to find union. Okay. But again, only works if they're disjoint. Okay, new example. Okay, so now we've got football team with 100 players, 30 that run the 40 and under 4.5, 20 that can bench at least 400, and 3 that can do both. All right. So we want to figure out how many can do either, and also how many can do neither. So obviously, a visual really helps here. So some people can do some of these in their head, but most of the time you're going to want to make a visual. So draw our Venn diagram. We have 2 groups. We have people that run the 40 and under 4.5. We're just going to call that group F. And then players that bench at least 400, we're just going to call that group B. So anytime we're doing these, always start as far into the middle as you can. So if you can find the intersection, that's where you want to start. Well, if we take a look right here, there's our intersection. 3 that can do both those. So there's 3 that overlap. Now we need to find out what goes in the outer parts. So if we go back to our information, 20 bench at least 400. So the B circle is 20. You already have 3 right here. So that means you have 17 left there. Okay, take note of that. The whole circle has to add to 20. That's a really, really common mistake. A lot of people will put 20 where I put that 17. Okay, we also have our 30 that run the 40 and under 4.5. So F, the whole F circle is 30. So that means we have 27 over here. Then we've got 100 total players. So what's left is we need to take, let's see, we have 30, 47. So 100 minus 47. There's 53 that are not very fast and not very strong. Sorry about those guys. But anyway, so question is now, how many can do either? So either, so one or the other or both, okay, Starbucks or. So for either, that's just 27 plus 3 plus 17, which is the 47. So 47 can do either. We just already found out neither. That's what's outside 50. All right. Moving on. Okay, so now we've got this rule called the addition rule. All right, so this is what we have non-disjoint sets, which is most of the ones you'll see are non-disjoint. Okay, we have a formula that we can use. Sometimes it's useful, sometimes a Venn diagram is easier. But here's what it looks like. So I have the number in my union is the total number in A plus the total number in B minus our intersection. So what it's doing is it's adding all of A. So let's just, I put that last example up here. Okay, where we had 40 in the bench, we had, let's see, 27, 3, 17. Okay. And we were told, so my first set, I think there were 30 total and 30 people. The bench press one was 20. And then the intersection was 3. You notice what that gives us, 30 plus 20 minus 3, there's that 47 that we found earlier. So this would be a case you could use either the formula or the Venn diagram if I'm trying to find the union. There'll also be times when I might know either, maybe I know the union, I know A, I know B, but I don't know my intersection. That's where the formula comes into play. That's what we're going to see on the next slide. All right, so take a look at this one. 100 people surveyed. 50 liked Pepsi, 40 said they liked Coke, 20 said they liked neither. We want to find out basically what is the intersection. So now I don't know my intersection. So if we tried to draw a Venn diagram, so Pepsi, Coke, we always like to start in the intersection. Well, I don't know that. Okay, so it makes it kind of tough to draw this Venn diagram. This is where the formula comes into play. All right, so my formula again, not probability, get a couple chapters ahead of you. So number in, what do we say, P, union C, plus a number in Pepsi, plus a number in Coke, minus the number in the intersection. If we take a look at these, I can figure out everything except the intersection, and I can just plug it in. So we're told number in P is 50. Number in C, so number of Coke, is 40. All right, and we're kind of indirectly told the union. We're told right here 20 liked neither, so there's 20 outside there. So if it's 100 total people, 20 are outside, and is the union. So there, and there has to add to what? 100 minus 20 has to add to 80. Okay, because 20 outside, 80 in the circles. So our union then would be 80. So my formula looks like we have 80 equals 50 plus 40 minus my intersection, and I like to I'll just make it X just so I don't have to write all that extra work. And I just need to find X. So 80 equals 90 minus X. So X has to be 10, right? 90 minus 10. There we go. Okay. So now we can complete our Venn diagram and we can answer our last question also. So the intersection was 10. We want to know how many prefer only Coke. Okay. Well, if 40 total like Coke, 10 are in the middle, over here has to be 30. So 30 only like Coke. All right, so that's where the formula kind of then can get you started on. Okay, get you going on the problem a little bit. All right, it's getting a little tougher now. So now I have 3 sets. All right, so we have 1,000 IU students polled, and then basically what classes they're taking. They have math, chemistry, psych. We have a certain amount are math and chemistry, a certain amount chemistry and psych, a certain amount math and psych, and then we have 30 that are all 3. All right, we want to know a few things. How many students, I'm not sure why the formatting did that, but how many students just take psych, just take math, just take chemistry, and then none of them. So set up a big old Venn diagram. So 3 groups. And it doesn't matter which you put where. I'm just kind of like, I go in order here. So I'll put math up here, then chemistry, and then psych. So remember what I said earlier, always start in the very, very middle if we can. All right, if you can't, it's a lot harder. In this case, we can. So if we look, there's our middle right there. 30 are taking all 3. Once I've got that, you can start working your way out. So, and I usually, a lot of times these are written, they're just kind of in order from the inside, or kind of from the outside in a way. So here's my very inside. I'm just going to go backwards here. So N intersect P, there's 40 of those. So N intersect P, so this part, I can draw this here. That part there is 40. So we already have 30, so that little empty spot has to be 10 because they have to add the 40 for N intersect P. And we can just keep going the same way if we keep working backwards. 70 are chemistry and psych, so that means this little open spot between chemistry and psych has to add to 70. That's a 40 there, because the 40 and 30 give you 70. 45, math and chemistry, so we have 15 there. And then I can start getting, because actually what it's wanting, how many just take psych, just take math, and so on. We can find those. That's what we have left now. So 155 are psych. So this whole circle for P has to add to 155. So 155 minus 40 minus 30 minus 10 should be 75 if I did that right in my head, hopefully. All right, and do the same thing for chemistry. Chemistry is 175 total, so 175 minus the 15, 30, and 40, that should be 90. And then for math, 135. So 135 minus 10 minus 30 minus 15 should be 18. Okay. So then we have our most of our Venn diagram at least. If I want to know how many just take psych, that's the 75. How many just take math, the 80. Just take chemistry, 90. Now none of them, that's what's outside. All right, this is the one that is a pain to do, especially without a calculator. We have 1,000 students to be started with. So what we have to do is subtract out basically everything in the circles. All right. So if you do that, you end up with, assuming that I did this calculation right, 660. Okay. So there you go. So that's the 3 sets. Okay, so now we're going to introduce another formula with this problem, because this is one that is very, very difficult without using a formula. Okay, so we don't know our farthest inside part. So 60 people in Switzerland, okay, my homeland. I'm Swiss, for those that don't know, or part Swiss. So we have 3 different languages there: French, German, Italian. Okay, if we look at this, so we have 25 that are German, 30, we have all these numbers, but we don't know this inside part. So you can set this up. There's one way to do it that's a huge pain. Like we can start here, F and I is 8. So you could write this as, this would have to be 8 minus X. You can have X's all over the place. It's awful to try to do. That's why there's a formula for the union of 3 sets. It's very, very similar to the union of 2 sets. I'm going to kind of show you how to do it. So I'm going to erase this and redraw something for you. So F, G, I. Okay, so here's my formula. We're going to kind of develop this. number in F union G union I. Okay, it's pretty long, but it's gonna, it should hopefully make sense once you see it. So that unit is gonna look like the other one with two sets. We start with number in F. I'm just going to put a little check mark for everything that we do. It's going to help us develop this formula. So F is everything in this circle, so it's all those. Okay. Plus number in G. So G would be, use a different color actually. That's helpful. Okay. That's awful. There we go. Sorry about my poor penmanship. So if I put G, if I put check marks everywhere in G, so that's there, 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 and there, plus number in Italian. So put check marks everywhere in Italian, so there, 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 and there. Well, if we look, I've got a bunch of overlap, right? Kind of like with the two sets we had to subtract the intersection. Well, now I've got a bunch of intersections. So let's start taking them out, okay? So if I take out F intersect G, so take a look on the Venn diagram, what that does. If I take out F intersect G, that gets rid of that check mark and that check mark. Okay, so now right up here, I don't have the overlap. Okay, let's take out another intersection. I'm just going to make a new line down here. So now number. So let's go. Let's do G intersect I. Okay, so if I take out G intersect I, so that's one of those and one of those. So now I'm good everywhere except for this little area over on the left. Where I still have two check marks. So that is F intersect I. Okay, so take out F intersect I. So it's there and there. Oh, got a problem now. We don't have anything in the middle. So we have the whole formula there, but we have nothing counted in the middle. Well, good news. It's very easy. Add it in. Okay. So now we took it out. Add it back. So that very inside part is F intersect G intersect I. And that puts it back. Everything's covered now. All right. So long formula, but I think it's easier to use. You're going to see why it's easier to use when we try to solve this now. Okay. So we want to know how many people speak all three. So I'm trying to find this right here. But I have everything else given to me. All right, I know my union. I know that. That's just a number that we're pulled because everybody spoke one of the languages. Or at least, I guess we assume. I guess I didn't give you that, but we'll assume everybody speaks all the languages. So 60 equals, okay, number in F would be 20. So total number in F. Plus total number in G, which is 25, plus total number in I, which is 30. Okay. Now we start taking out our three intersections. So F intersect G, so that's French and German, there, 8, minus G intersect I, so German and Italian, 9. Minus F intersect I, so F in, it's fine, I made a mistake, I'll get that in a second. F intersect I was 8 also. Okay, I just noticed that I did give you the information about, the 6 spoke none of them, so actually this is not a 60. 6 is outside, so that is a 54. Okay. And then so I've got all this. That was so F, G, I. German, Italian, French and German, German, Italian, French, Italian, and then I need to add in what I don't know, which is that inner part to speak all three, so X. And then I just have to solve that for X. Okay. I'll leave that for you guys to do. You guys can add numbers together. All right. Last example. This is a lot quicker. So A and B are disjoint subsets. So let's draw A and B. So my universal set U. There's A. There's B. The whole deal has 45. Let's write that above. A is 12. Okay, there's no overlap, so I can just put the 12 right in. B complement is 22. So not B would be complement. Okay, so everything not in B. So, well, we have 12 that are not in B, 22 total not in B, so that leaves 10 to be sitting outside there. Okay, and then now we just need to figure out what's in B. Well, 10 and 12 is 22. There's 45 total, so that's 23 in B. Okay. So Venn diagram done. Now we need to figure out my symbols. So not in A, intersect with B. You might remember what that is just from the last section. If you don't, okay, remember, easy way to do it, whether we're intersected or not. So put a check mark everywhere you see A complement, so that's everything outside of A, so there and there. Put a check mark in everywhere in B. And then if it's intersection, that means it's shaded or checked. I still have shaded in my head. Checked twice. Well, where's checked twice? That part that's only B. So we want only B. 23. There's our answer. Okay. There we go. So that is section 1.3 on sizes of sets. And I will continue to try to end this with, but my computer is not letting me.